Sound. Range of hearing. We know that sound is a longitudinal mechanical wave of any frequency. The frequency of sound wave determines its tone and pitch. The frequency range of a young person is about 20 to 20,000 hertz. The human ear is capable of hearing many of the sounds produced in nature, but certainly not all. Some low frequencies, like a heartbeat of 1 or 2 hertz, cannot be heard. Just like sonar sounds produced by dolphins, which are too high. Any frequency that is below the human range is known as infrasound. It is so low that it may be detected by a creature with big ears, such as an elephant. In fact, recent research indicates that elephants also communicate with infrasound. Ultrasound, on the other hand, is about the range of the human ear. Bats, whales, porpoises, and dolphins use ultrasound for navigation. Most bats can detect frequencies as high as 100,000 hertz. Did you know? Bats use high frequency, that is, low wavelength, ultrasonic waves in order to enhance their ability to hunt. The typical prey of a bat is the moth, an object not much larger than a couple of centimeters. Bats use ultrasonic echolocation methods to detect the presence of bats in the air. But why ultrasound? The answer lies in the physics of diffraction. As the wavelength of a wave becomes smaller than the obstacle which it encounters, the wave is no longer able to diffract around the obstacle. Instead, the wave reflects off the obstacle.
Bats use
Ultrasonic waves
with wavelengths
smaller than the dimensions of their prey. These sound waves will encounter the prey and instead of diffracting around the prey, will reflect off the prey and allow the bat to hunt by means of echolocation. Let us now study the applications of ultrasound. Ultrasounds are high-frequency waves. Ultrasounds are able to travel along well-defined paths even in the presence of obstacles. Ultrasounds are used extensively in industries and for medical purposes. Ultrasound is generally used to clean parts located in hard-to-reach places. For example, spiral tube, odd-shaped parts, electronic components, etc. Objects to be cleaned are placed in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequencies, the particles of dust, grease and dirt get detached and drop out. The objects thus get thoroughly cleaned. Ultrasounds can be used to detect cracks and flaws in metal blocks. Metallic components are generally used in construction of big structures like buildings, bridges, machines, and also scientific equipment. The cracks or holes inside the metal blocks, which are invisible from outside, reduces the strength of the structure. Ultrasonic waves are allowed to pass through the metal block, and detectors are used to detect the transmitted waves. If there is even a small defect, the ultrasound gets reflected back, indicating the presence of the flaw or defect. Ordinary sound of longer wavelengths cannot be used for such purpose, as it will bend around the corners of the defective location and enter the detector. Ultrasonic waves are made to reflect from various parts of the heart and form the image of the heart. This technique is called echocardiography. Ultrasound scanner is an instrument which uses ultrasonic waves for getting images of internal organs of the human body. A doctor may image the patient's organs such as the liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect abnormalities such as stones in the gallbladder and kidney or tumors in different organs. In this technique, the ultrasonic waves travel through the tissues of the body and get reflected from a region where there is a change of tissue density. These waves are then converted into electrical signals that are used to generate images of the organ. These images are then displayed on a monitor or printed on a film. This technique is called ultrasonography. Ultrasonography is also used for examination of the fetus during pregnancy to detect congenital defects and growth abnormalities. Ultrasound may be employed to break small stones formed in the kidneys into fine grains. These grains later get flushed out with urine. We have studied the industrial and medical applications of ultrasound earlier. Let us now understand applications of ultrasound in underwater processes. The acronym SONAR stands for Sound Navigation and Ranging. Sonar is a device that uses ultrasonic waves to measure the distance, direction, and speed of underwater objects. How does the sonar work? Sonar consists of a transmitter and a detector as installed in a boat or a ship. The transmitter produces and transmits ultrasonic waves. These waves travel through water and after striking the object on the seabed get reflected back and are sensed by the detector. The detector converts the ultrasonic waves into electrical signals which are appropriately interpreted. The distance of the object that reflected the sound wave can be calculated by knowing the speed of sound in water and the time interval between transmission and reception of the ultrasound. Let the time interval between transmission and reception of the ultrasound be t, and the speed of sound through seawater be v. The total distance 2d travelled by the ultrasound is then 2d is equal to v into t. The above method is called echo ranging. The sonar technique is used to determine the depth of the sea and to locate underwater hills, valleys, submarines, icebergs, sunken ship, etc. Let us revise what we have learned. For hearing a distinct sound, the time interval between the original sound and the reflected one must be at least 0.1 second. The persistence of sound in an auditorium is the result of repeated reflections of sound and is called reverberation. Sound properties such as pitch, loudness, and quality are determined by the corresponding wave properties. Loudness is a physiological response of the ear to the intensity. The amount of sound energy passing each second through unit area is called the intensity of sound. The audible range of hearing for average human beings is in the frequency range of 20 Hz to 20,000 Hz. Sound waves with frequency below the audible range are termed infrasonic, and those above the audible range are termed ultrasonic. Ultrasound has many medical and industrial applications. The sonar technique is used to determine the depth of the sea and to locate underwater hills, valleys, submarines, icebergs, sunken ships, etc. That is it for now. Remember, whatever you hold in your mind will tend to occur in your life. If you continue to believe as you have always believed, you will continue to act as you have always acted. If you continue to act as you have always acted, you will continue to get what you have always gotten. If you want different results in your life or your work, all you have to do is change your mind.